Welcome to the Nengi Beta 2 intro video. This will be a pretty casual video where I run through Nengi Beta 2 and the example game that shipped with it. You can download it on the Nengi site in the download section, and you can install it with npm. There's some troubleshooting and some tips down here where you can read if you run into problems. You can also email me if this doesn't work for you. I've got it up and running. And I'm going to start it by typing npm start and show you what it looks like. Game should look like this. Actually, make sure that your cache is being cleared, especially if you've opened a few Nengi examples today. It will try and load the old game. So there we go. I had something else cached there, slightly different version. So game looks like this. It's got the art from BrowserQuest, which is open source and released. There's a link to it in the downloads if you want to see the license and all the details and also find the rest of the art. It's a lot more than what's just used right here. The big feature of Nengi Beta 2 is instance-to-instance transfers. It's a feature where the server can transfer a client to another server. It is illustrated here with this cave because here we are on a server which is loaded up the overworld map. And when we touch this cave, it will send us to another server. That server has the underworld map, which is this cave. Not the most amazing feature, seemingly, right? We've seen this in a million games, being able to enter a house, being able to enter a cave. What's special about this is that these are on different servers, meaning that you can horizontally scale a game indefinitely, really. With this, you can make a game where you fill up each zone with as many players as the game in particular can handle, whatever that is, maybe 100. And then you can connect other zones to it, and they can connect, indefinitely, and you can have a game with 10,000 players. That's how most MMOs work. There aren't 1,000 players in one spot ever. There's 50, there's 5, there's 100 sometimes, and the majority of the world is made with numerous little instances. That's how WoW instances work. They actually call them instances in WoW. It's also how all the areas in Guild Wars work. Guild Wars having this other level of cleverness where if any particular area of the game gets overly full, it makes a copy of that area of the game, and anyone else who tries to enter it enters the copy. So there can actually be a dozen of the zone that you look like you're in Guild Wars, and you're just in one of them. So all that is now possible with Nengi. And I'm excited to see what people make with it. The other feature that was closely related and a prerequisite for that was some sort of authentication of the clients. The authentication is nothing to really see in this demo. This demo lets everybody who enters the game play the game. It's something to look at in the code, and it's the only real change to the Nengi API since the prior version. The rest is all the same. In any case, connection code in Nengi is a little different now. The client the client doesn't have to do anything really. The client just connects to an IP. Here it is, line 27. But the client can now optionally attach some data. You can attach some sort of object here, just think of it as like JSON, it can be whatever, and it will send that and the server will receive it. Now, when programming in Nengi, we try and follow an authoritative server model. That means that anything that comes from the client, we don't trust. So don't use this to send anything from the client that you expect the server to trust. Use this to send things to the server that the server can be very skeptical about. So don't say, hey, I'm connecting to your server, let me log in as this one character, because then somebody can, hack their client, they can find the name or the ID of somebody else's character, and then they log in as them. Instead, we do something more roundabout. For example, the web page could give the player a session, or you could authenticate them just in a normal web page style of authentication. And then upon connection, you could pass your cookie through the WebSocket to the server. It would then arrive at the server. Let's go look at what that looks like. Server, game server. So over here, this is the connect handler for a client connected. There's this argument called client data, which holds whatever was sent from the client. Over here in the server, you can take a look at that client data and you can figure out what you're going to do with this client. In this particular game demo, like I said, everything is just accepted, so it just pretty much assumes it's going to work. It spawns them a player and it tells them, it responds by saying, oh, you're accepted. But in an authentication scenario, we could take that session and we could then ask our other server, the server that issued the session, be like, is this a real session? Who is this? What player is this? And we could obtain some data. Potentially, in like an MMORPG, we could even obtain their player character and then load it into the game here. So that hook exists for authentication. And it also is related to how the transfers work. So these two things come together in this version. Other things everything else that's cool about this particular game comes from the game demo itself, not any particular change to Nengi. The changes to Nengi were limited to the transfers and authentication. This game itself has some things that people have been asking me to show how to do. For example, it's got a tiled map. It's got it's got a camera that follows the player. And it's got some sort of screen scaling associated with it. Now, this is pretty much Pixie-related code here. You can look in there and see how it works. This particular screen scaling is pretty crazy. It can do anything from an iPhone to 4K. This screen isn't 4K, so I guess I can't prove that, but it would go forever. This one works by scaling the pixel art to even integer numbers, so it scales it times 1, times 2, times 3, never times 1.5 or any non-integer. And it fills the rest of the space by adding tiles or removing tiles from the edges. The other thing about this code that people have wanted is the illustration of a tiled map that can be very large. This map in particular is 100 by 100 tiles. It's got 5 layers, though most of the layers are empty. It has some special code that allows for rendering a map that is really, really big. Not infinite, but so big that it's just dumb how big it is. You can see this code in World Renderer, which is in the client. All it does, well, I'm not going to talk about it too specifically, but conceptually what it does is it finds an area around the player and shows those tiles and doesn't ever load any of the others. And then as you move around, it changes which ones it loads. So it's never loading the entirety of the map, which is why it can do a very big map. The map itself is made in tiled map editor, which I will show you and show you how it's all connected to Nengi and Pixie and all this. So in this game, there's a folder called Creative. Creative has some of the raw assets for the game. It's got some animations for a sprite sheet, which I'll show in a moment, and it's also got a folder called Maps with the actual map data files. This is not what the player loads. These maps get saved as JSON and put somewhere else, and the player loads those. But let's go look at the actual raw maps. I'm going to open up tiled map editor, and let me close whatever it had open and make sure I open the actual file from this game. Beta 2, tiled creative maps. So I'm opening the overworld map. This is the actual map that when we export gets loaded into the game. So I think you can see, you can probably recognize it already. Looks like this area. This is pretty cool, tiled. There's tutorials about it, you can look into it. But essentially you make a little palette and you can just paint with your tiles. Like you just take it's like using MS Paint or something. You just take your tiles and you just draw on it. So pretty sweet, pretty productive. Let's see. Let's prove that this is working. Let's just add something to this map real quick. Export it so you can see how it works and get it loaded up again. So let's add, I don't know, let's add another cactus. Actually, no, cactuses are complicated because I do this thing with the foreground and the background so you can walk behind it. Let's just add some random tiles over here. So this is near the spawn area. We spawned in front of that cave, so I'm just going to draw some of this here. Wonderful. I'm going to save it. and then I'm going to export it. The export is the version that actually gets loaded in the client. And let's see, it is in the public folder where the HTML is and the other assets for the game. Let me navigate to that though, because I've gotten myself lost. NG Beta 2, tiled demo, public, maps. So there you go, overworld. Yes, we will overwrite it. So now, if I refresh this game, will we see it? I hope so. Oh, there we go. So, as you can see, pretty awesome workflow, right? Went from drawing in here, exporting it, and then refreshing the browser, and there we were, the change was live. This map also has some other cool stuff in it that's not just visual. It has this collision layer. That's a layer of the map where I've drawn this blue X thing here, and I've just drawn anywhere that I've decided is going to be a collision for the player. Let's just add some arbitrary one to test that. So there we have it. I've drawn that stripe. I'm going to save it. I guess I don't actually have to save it. I only have to export it. Let's see if it exports to the exact same place. Does it do it? Does it remember? I think it remembers. So the server side of the game uses the collision map, this collision layer, and the client side of the game uses all the graphical stuff. So that will involve restarting the server to make sure that these changes have taken effect. Now, I don't know if this little monitor program knows that that changed. I'm just going to refresh and just see what happens. I would suspect that we'd need to manually restart the server. Oh, cool, the monitor program even understands the map changing, so that's awesome. So I drew those little like collision map things here on the edge here, and you can see I can't move into them anymore. So that's tiled being used. Pretty awesome. Let me delete all that stuff. Actually, we'll undo it. Save, export. So cool that node mod can actually detect this stuff changing. So let's refresh. Can I run through all this area? So there you go. There's tiled and making changes in the game extremely quickly. Awesome stuff. There's also the map for the underworld, which is, there's not a whole lot going on in there, but there it is. So that's tiled being used. And let's see, do I want to say anything else about tiled? Well, it really works thanks to a little exporter that is included in this demo that understands this JSON format that you can save the tiled maps and exports it into something that Pixie understands. Here it is. I called it tiled loader middleware. Followed a Pixie pattern for loading it. You can add features to it. Tiled has a ton of features. All I wrote is enough to get this map in there with the tiles and all that. But Tiled has other features. You can like draw areas, like arbitrary polygons on the map, and you can load them into your games too. And you'll have to write some logic that does something with them. You know, like uses them as the rescue zone or the escape zone or whatever. But there's a ton of stuff in there, and this loader only does some basic graphics. What else do I want to show off that's connected to this demo? Oh, the animations. So there's very simple animations. There's idle animation in 4 directions. It's just him moving his shoulders up and down. I did not draw any of this. This is just the browser quest, little hero guy. And there's walking in 4 directions, probably in 3 directions then invert. So also showing Pixie in specific being used and a program that works with Pixie. These animations are packaged in Texture Packer. Whoops. Texture Packer. Texture Packer is a program that lets you can use a free version by the way, all of these things are free, that lets you basically have a folder on your hard drive where you put a bunch of images, separate images, and it will pack them together into a single sprite sheet, and it makes this JSON file that says where in the sprite sheet all the stuff is, and Pixie knows how to load it up so that you can just refer to them by name. Let's see, am I in the right folder? I gotta open. So also in that creative folder is this file that is the Texture Packer project. Not that there's a whole lot to Texture Packer project. It's essentially a folder. Demo, where did I put creative, sprite sheet, master.tps. Okay. So here you can see the sprite sheet. I mean, it's tiny pixel art. I gotta zoom in for this to even be visible. But these are all the frames for the little dudes run animation. And it can export it too. I'm not sure how fragile these file paths are, whether they're hard-coded, but over here you can publish the sprite sheet, and that's when it turns all the sprites into the actual sprite sheet. Let's go find it. Inside of the public images folder is where I told it to go. So here's a sprite sheet JSON, just a bunch of machine-made data. Here's the sprite sheet, there's that file again. And here's the tile sheet, which goes with the maps. Let's see. We can look at the animation code briefly. There's not a whole lot to it. It's in client entity, example entity. I guess this is probably too big even for this. So I just made some very brute force, verbose demonstration of an animation in Pixie. On the update, it keeps track of time, and depending what state we're in, moving and where we're facing, it basically increments a frame counter by 1, animation frame plus plus, and then switches to the frame. It repeats itself. This can be done a different way, but there's an illustration of an animation as well in Pixie. Anything else in this project worthy of mention? There's an input system, just takes the keys WASD and the mouse position, though it doesn't use the mouse position for anything. But I put that in there in case you want to add to it. Nothing too special about that. Regular DOM, just getting the keystrokes from the browser. So I think that's all the cool stuff from this demo shown. And all the graphic stuff. We did tiled, we did texture packer, and we saw the game working. So that's all. Hopefully that helps. You can email me if you have questions about how all this works. Thanks.